Hey guys, how are you doing? Welcome back to the Golang and DynamoDB Bulletproof CRUD project series. So we were done with quite a lot in this project. Till now, we've done quite a bit. So the only thing that's remaining is finishing the create table function in our rules product file. And then what we'll do is we'll fix all the things. And to save your time, I won't fix all the everything or the typos and the errors in front of you. I'll fix everything and I'll push it to GitHub because it'll take me approximately 30 minutes to fix everything. So I don't want you to waste your time with me on that. And I'll fix everything in the background and I'll push it to GitHub. And I'll put the GitHub link of this entire code, right? Everything debugged for you. You'll get everything on a platter. So everything will be debugged for you. I'll put it on GitHub. You just have to make a copy of that and just compare your code with this, and then everything will be fine. But what I will do is I'll show you how to run this code, right? So we'll run it together right now. So I'll take like a 30 minutes break in the video, and then I'll show you how to run this code. And that will be it for this series. That's how I've planned it for this video. So in this file, what's really missing actually is the packages that we'll need. So we'll be needing packages like the github.com/aws/aws SDK go/aws package. Okay. And we obviously need the DynamoDB package, so I'll get that also. .com/aws SDK go/service/DynamoDB. And I need a validation package out here. This one. So even though I've used it in my program already, I have not imported it. So validation is basically github.com/go also validation/v4. And then you have inside that same validation package, you also need one more package. You need github.com/go also validation/v4/is. And then you need the UUID package because we've used it here. So to get the UUID package, we'll have to say github.com/google/UUID. And obviously we have our IO strings and time and errors and encoding JSON. But I need my entities and products. So what I'll do is I'll go to the internal product.go file and I'll just get this line from here so that I get access to the project name and everything. But here, instead of this, inside my internals, I need access to my entities and I need access to my entities product. So that's that. Now, what you want to do is you want to quickly finish up your create table function. Now we already know that this is a struct method and not just a simple function. Okay. So we'll say R rules and create table. This function takes a connection. Now, everything that I'm doing in this function has been taken from the AWS DynamoDB library, the DynamoDB library that we're using here. And none of the code that I'll be writing here is my own code. I'm taking it from the DynamoDB documentation directly. So DynamoDB says that before you start using the tables directly, you have to ensure that the tables exist. So you'll have to create the tables yourself when you instantiate the connection with DynamoDB. I mean, you don't have to do that with MongoDB. You've already seen that in my other videos. So MongoDB automatically creates that table or that collection for you. But that's not the case with DynamoDB. So with DynamoDB, you'll have to create that using this create table function. So like I said, all of the code that I'll be writing here has been taken from the documentation directly. So feel free to copy it from my code directly. You don't have to bother too much about it. I'll still explain the things to you. I'll still explain what's happening to you. But even if you don't understand it, it's okay, because you'll be using the same code in all of your projects. So you just have to copy this function always, and you'll be using it everywhere. So we'll take a variable called table, and we'll say it's product. And then the DynamoDB package the library that we want to access, has this function that's the most important function here. It's called create table import function. For the input that you'll send to the table. And all of that can be captured in this variable called input. And like I said, this is the part where we are now referring to the documentation, which is attribute definitions. This is saying DynamoDB attribute definition, attribute name. Attribute name you'll get from your AWS package. So you'll say AWS dot string ID and attribute type. So you're telling DynamoDB that, hey, this table will have ID and it will be of type string. So this is the type string. And you'll put a comma here, put a comma here. Actually, there's one more bracket. Supposed to be one more bracket here. So we'll put a comma here, comma here. So this was the bracket for the attribute definition. Now at the same level of the attribute definition, you want to have something called as the key schema. So you'll say, and mind you, they're all inside this create table input bracket. So you'll say key schema. Again, you'll refer the same slice, which will have pointers to DynamoDB.schema element, key schema element. And here again, you'll create those two brackets, put a comma here, and here what you're saying is, again, the attribute name is aws.string underscore ID, and then you're saying key type aws.string hash. Then you have to go ahead and define, again, this is the requirement from DynamoDB. You have to define something called as the provisioned throughput. Again, you'll refer the DynamoDB library and you'll get a function called provisioned throughput. It has two variables, read capacity units and write capacity units. This is an integer of size 10, and this again is an integer. Sorry, with value 10, I meant. And then the last thing that you'll define is table name, which again string, and you'll use the table to get access to the table name. Now after this bracket, which I'll just format a little bit properly, After this bracket, you want to define, you want to start a connection to the create table, and you'll send all this as input. So we'll say connection.create table, and you'll capture that in a variable called response, or you'll handle the error. So to handle the error, what you'll do is you'll say if error is not equal to nil, and the strings contains error, then the table is already there. So you're trying to create the table, but it's already there. So there was no need to instantiate this. And you'll return nil. Whereas if the response is not equal to nil, and the string contains response.goString, then you'll say that I'm creating the table. So you'll say table status is, you'll have to put a little bit of escape characters here, creating. And you'll say time. So in this if statement, you'll say time.sleep for 3 seconds. And you'll create table with a connection. Just a connection, no need to pass the table. And you'll handle the error. So if error is not equal to nil, you'll say return error, and at the end, return error. So that was it. You can see that there are 2 issues in this file, 2 errors it's showing me. But I'm sure there are just so many more, right? I know that there are many more errors. So what I'll do is I'll take like a 30-40 minute break, and I'll fix all the errors. I'll push everything to GitHub, give you the link, and then we'll test this program together. What do you think? All right, so I'll see you in, like for you it'll be just 1 second, but for me it'll be like 40 minutes space. So I'll see you in 2 minutes. So I'm back and I have fixed the entire project. I'll be putting it on GitHub shortly, but I just wanted to show you how to run this program. So this is our folder that we had created, and it has the CMD folder, right? So you want to go inside the CMD folder, you want to go inside the app, and this is where you get the main.go file. And you want to say go run main.go, and it'll take a while to start off the service for you. And see, this is what we expected. We wanted it to say table found, and all these tables have been found. It's running on port 8080. Now, this is my Postman, and Postman we have 1, 2, 3, 6 different routes to test whatever we've done till now. So in the health check, which is the first route, what we've done is I've said localhost 8080 and /health. So you send, and you'll see that the status is 200. And the result is service. Okay, that means it's working. Now, it comes time of post. So for the post request, what you'll do is you'll say HTTP localhost 8080 and /product. And here you can put any product. So let's say you put a product called wafers, and you create the product. So it says 200, and it gives you the ID of the product. And the best way to check if all the products are there is to say get all, which is basically a get request on HTTP localhost /product, and you'll send, and you'll get all the products that I've created till now, including the one with the wafers. And if we want this particular product to be shown to us, so we'll take this ID and we'll go to get by ID, and we'll put it here. We'll put the ID here, and we'll say get by ID. Now to update the product, what you'll do is you'll go and put the ID there, and I'm going to call it, let's say something like chocolate. And it says 204 no content because we're not returning anything. We're not saying anything that this has been updated. But if you go and check the get all, you'll see that basically that there's a chocolate product here now. All right. And for the delete, it works in a very similar way. You open that and you take the same ID, and when you paste it here, now just a pointer, for the update you have to use the put method, for the delete you have to use the delete method, and when you send it, it again says 204 no content, just like the update method, but the data has been deleted for sure. So you go here and you see that the one with the wafer is not there. It has been deleted now. So basically this is what I want to show you, these 6 different what do you call it, that's the complete CRUD, basically 6 different APIs working perfectly fine with DynamoDB. It's a bulletproof CRUD system. This project has taken quite a long time. It is a lot of code, and this is why this is why I kind of broke it down for you. I explained to you every function, and this is for experienced developers only. So this is why I didn't explain every single line, but I did break down the functions for you. So you know the file structure, you know the project structure, you know what each function is doing, you know each file, what each file is doing, and you know how the whole project structure. But each line, sometimes I was not explaining it to you, but I'm very sure if you're an experienced developer, you have understood the entire project, and you've at least you know how to bring all these things together and build a project like this. And the best benefit is that you get this project on my GitHub. You just copy and use it. You just change the routes, change the CRUD functionality, and you're good to go. You have a great project structure to use in all your future projects, right? And I am using this for a product of mine, a smaller product that I've built previously for a client. I use this exact structure, so I can tell you that it will scale really well, because you can work with 5-6 team members as well. It can handle at least for that particular client that I'm talking about, it's handling more than 6,000 users, and concurrently about 500 to 600 active users it's handling. So I can tell you that it's a very, very stable project structure, and you won't face any problem till about 10,000 users. I can tell you won't face any problems with this. So this was it from my end, and thanks a lot for watching, and do subscribe to the channel if you haven't already. But I think you would have subscribed. That's why you've watched this whole series, entire series. Thank you for watching, and I'll see you in the next video.